Hey everyone, I just want to do a couple examples for you on writing ranges. Now, if you already know how to do this, then you most certainly don't have to watch the video, but for those of you that wanted a little help on it, I wanted to give you that opportunity so you didn't have to wait for me to come to you. So whenever we're working with ranges, remember we're focusing on how far up and down the graph extends. So what I like to do is kind of put I don't want to say a box, but a lower limit and an upper limit line on my graph. And I just want to see what numbers that those lines intersect the y-axis at. And so my lower limit looks like it's at 1, and my upper limit is at 5. And since there are both limits on the top and bottom, we're going to make sure that we have an interval here where y is in the middle. And notice this time we're using y instead of x because we're dealing with the y values on the y-axis. So my lower limit is 1, my upper limit is 5, and since there are not any open circles on the top and bottom, there's nothing open, that means it actually reaches that number on the y-axis, so we are going to include the less than or equal to symbol. Okay? Looking at the continuity piece or the continuous piece, we most certainly can draw a circle without picking up our pencil. So we'll say, yes, it's continuous. And it passes the vertical line test, or I'm sorry, it doesn't pass the vertical line test because there is at least one line that intersects the circle more than once. And so this is not a function because it intersects a vertical line in more than one position. All right, we'll do a couple more here. So on number 2, we have definite high and low values, and it's not just where the endpoints are. It's literally the lowest part on the graph and the highest part on the graph. So here, the lowest value, if you look here, occurs at -4 on the y-axis, and the highest value occurs at 3. So 3 is the upper value. -4 is my lower value. I'm going to rewrite that so it's a little cleaner. Lower value is -4. Upper value is 3. And if you look at the top of the graph, again, we're not looking at the middle of the graph. We're looking at the top and bottom. On the top and bottom, this is a closed circle. So that means we're going to use a less than or equal to on the top number. Okay? At -4, again, this is not open. It's technically closed, even though they didn't put a dot there. You can assume that if it's not open, you can assume that it actually does reach that number. Okay? To decide if it's a function, again, we'll just look vertically. And if I draw vertical lines throughout this graph, it never intersects the graph more than once, and so we'll say yes, it is a function. Okay, now number 3, for whatever reason, this image got deleted, and so go ahead and draw an arrow kind of pointing downward and to the left. It doesn't have to be perfectly matched up with mine, but follow that general pattern. And I'm going to start with the continuous piece to begin with, and so if we look at starting where the endpoint is and drawing to the left, I can draw that entire graph without picking up my pencil. So yes, this is a continuous graph. Okay, the range, this time, we only have an upper limit. I can't stop at a lower value because this graph, you can see the arrow, even though it's not at an extreme rate, it is continuously moving down and down. And so this is going to be my upper limit, and then there is no lower limit. So the upper limit, remember, always goes on the right end. If there is a lower limit, it goes first. So since there's no lower limit, I'm just going to start with my inequality here. And since it's an open circle, we're just going to have a less than symbol with no equal to. And we just want to look at what number on the y-axis that lower limit starts at, or excuse me, the upper limit. The upper limit starts at -2. So that means all of the y values on this graph, all of these points have y values that are less than -2. Okay? It does pass the vertical line test, so we'll say yes, it is a function. All right, let's try the last one here. This will be very similar to yesterday. The only difference is now we're looking at, again, the y-axis. So I'm going to look every time I see a point on the on the graph, I'm going to put a mark on the y-axis. And what we're going to do is list our ordered pairs. So starting kind of at the lower side, we have -1, -1. Over here I have 3, 1. And I have 3, 0. I have -3, 1. We have -4, 3. We have 1, 3. And we have, it looks like -1, 4. All right, now, since we're doing range, we only want the y values. So I'm going to highlight all of my y values on those ordered pairs. And just like yesterday, we're going to list them small to big. And we don't have to include any duplicates. Okay? It's not a continuous graph because these are just considered discrete points. They do not all connect together with a line. All right, you could draw a line, but right now there is no line on this graph. So our range is, again, it's just going to be the list of the y values from small to big. So I'm going to start here with the smallest one at -1. And the next, and again, there's another, oh, that was supposed to say -1. There's another -1, but we don't have to list it twice. So now I'm going to go to my 0. I'm just going to circle them after I use them. Okay, after 0, numerically would come the 1. And then notice we have double 3s here, but we only have to include it once. And then the highest y value is 4. All right, so it's just a list of y coordinates that represent the spots on the graph where we have points. All right, and then I'm just going to check the vertical line test here. That only intersects once. But here we intersect twice. Since it intersects the graph more than once, it does not pass the vertical line test, so it is not a function. All right, hope that helps. Bring up the backside when you're finished, and we'll give you some feedback and see how you're doing.